Hi everyone, welcome back to the channel. In today's video, we're going to take a look at Apache Iceberg and how that can be used in AWS. Do you face the situation on a daily basis where your data lake queries are slow, you're struggling to evolve your partitions and schemas, you can't get ACID transactions, and performing tasks such as updating the data at scale is timely and costly in terms of your ETL jobs? Well, don't worry. Apache Iceberg could solve these issues for you. Created by Netflix on S3 in AWS to increase the query performance, the ability to insert, update data, give ACID transactions and time travel, it is the ideal tool for your AWS data lake. In this video, I'm going to give you a little bit of theory on how Iceberg actually works at the table level to give you query performance and schema evolution. Then we'll jump onto the console and do a hands-on tutorial together. I've made all the resources for free on GitHub, link in the description below where you'll need to download them to follow along. With that all being said, I'd really appreciate a like and subscribe, and let's jump onto the computer and get going. Before we jump onto the console and actually carry out the tutorial, I'm just going to spend a couple of minutes explaining how tables are created in Apache Iceberg and what that actually looks like on S3. It's a good understanding to have so you can be aware of it as we go through the tutorial and how the queries are actually executing. So this is what Apache Iceberg looks like. I know there's quite a lot on this diagram. In the next couple of slides, I'm going to walk through how this is built up from a create table statement, insert and update. So don't worry at this stage about understanding everything. This is just how it looks once you've actually inserted data into a table. So the important things here is the Iceberg catalog. In our case, it's going to be the glue data catalog. And all it contains in terms of an Iceberg table is a pointer to the metadata. So you can see below that we have a metadata layer, and this is the data that Iceberg holds in S3 in a metadata folder, which I'll show you in just a little second. And in that folder is manifest lists and manifest files. These lists and files contain information about the data files below and how the table looked at a certain point in time. So S0 is snapshot 0, and how that table looked for S0 is held in a manifest list that contains a list of manifest files, and those manifest files point to the data files that made up the table at that point in time. And then if we look on the right hand side here, we have snapshot 1, which is further into the future when we've altered the data. It contains or points to a manifest list that points to manifest files that point to data files and how that table looked at the point in time for snapshot 1. And this is how we have the ACID principles and time travel for Iceberg. Because we know the table looked like this at snapshot 1, if we were writing new data, then we can still query as it looked at snapshot 1 while we're writing data. Once the data is complete, it would form snapshot 2, and then our queries would start to run down snapshot 2. So we can hold ACID transactions throughout the process of updating and deleting that data. Let's take a quick look at how this actually looks on S3 before we go through the process of how to build this up on the slides. You will be doing this in the demo, and I will point it out again, but if we click up here, this is our folder that makes up our Iceberg table, and again, we will be doing this in the tutorial, but you'll see that there's a data folder, so that's where the data is held. So if I just quickly jump back onto the presentation, that's the data layer. So the data folder is the data layer, but this metadata layer, so there's a metadata layer that you can see here, is contained in this metadata folder, and this is a list of different files that contain that manifest list and that metadata together. So you can see that there is a distinct split when it comes to storing this information on S3. Let's jump back onto the presentation and see how this is built up from a create table statement to really cement that understanding. Okay, so let's go to a create table statement and look at how this is built up. So this is a table that we'll be creating, and the first thing it does is store that current information about that table and where it points to on S3 in the Iceberg catalog, in our case, the glue data catalog. Next thing it does is create a metadata file in that metadata folder, and this is S0 showing snapshot 0. We have no data in this table, so this is where it stops for the create table statement. Next, we insert data into the table, so this is just one row to show how it works. What happens is that a new pointer is created inside the table, and it points to snapshot 1, or where snapshot 1 is contained in the metadata file. Snapshot 1 points to a manifest list. This list contains the manifest file or files, and those files, as you can see here, point to the data. So this is the data that makes up snapshot 1, and when we run a query, we say select star from the NYC taxi Iceberg table. It goes down and says, right, we're at snapshot 1. What does that look like? Okay, this is the manifest list. These are the files that make up the manifest list, and here are the data files that belong to snapshot 1. Query these files. However, the manifest list actually contains information about the files below, such as max and mins and what's in the files. So when we write a query in Iceberg, before it reads the data files, it knows exactly what files to grab for that point in time that contain the data we need for our query. And that's why it's fast at actually doing queries themselves, because it knows what data files it needs to grab from the data layer before the query is actually executed. So it works that out at planned time. Next, if we do an update, then we create a snapshot 2. So this is the next snapshot along in the list. It points to a series of manifest lists. That list contains manifest files, as you can see again, and those manifest files contain the data files belonging to snapshot 2. So snapshot 2 has these data files belonging to it. And if we run a query, then it says, oh, I need these data files to give me the answer for my query. Time travel then comes into play here. If we want to look at how the data looked back in the past, say where snapshot 1 was, then we run a query. It knows to go to snapshot 1, get the manifest list here, get the manifest files, and give us how the data looked at a period of time before we ran this update statement. So it's giving me the data how it looked in snapshot 1. This also gives us ACID transactions to ensure that we're not reading dirty data as it's changing. Because we point to a snapshot at a point in time, when we write a query, then our queries go down and get the files for as it looked at that point in time. If we then ran an update, then everyone would be going down the new snapshot. The snapshot is only committed once the data files are wrote, so we don't get dirty reads in the middle of a select. We're always looking at a complete snapshot from a point in time before we move on. So with that in mind, let's jump onto the console and create these tables and then get hands-on in the tutorial, actually manipulating the data and looking at how Apache Iceberg works using AWS Athena. Okay, so the first thing we need to do for this tutorial is download the code and sample data on GitHub, which I've supplied the link for in the description. Go there and click download as zip. It will download the file as a zip. Double click that opening, and then it will take the zip file and extract it for you so you have everything that you need to run. The main things are the data folder and the CF resources YAML. Next, let's log into the AWS console and we can spin up the CloudFormation stack that's going to create some resources. Once logged in and on the AWS console, go to CloudFormation. So type in cloud, then formation in the search box and click on it. Once loaded, we're going to create a new stack with resources. Template is ready. Upload a file template. Choose file. We need to navigate to the folder that we downloaded and unzipped. So I'm inside my downloads folder. So if I go into my downloads, Iceberg main, and it's the CF_resources file that we want. Let's choose that file and let's go next. You need to give your stack a name. So I'm going to call this Johnny Iceberg, and we can use this to delete resources at the end. The other thing you need to do is give a name for your S3 bucket that you'll use throughout the tutorial. This must be completely unique within AWS, not only inside your account. So I'm going to go Johnny Chivers Iceberg demo. Put your own name if it's quite unique, and then some form of letters or numbers that you know afterwards, and that should do the trick. This is all fine. We're going to use the I am role that we're logged in. I do have admin permissions currently, so just bear that in mind. I'm using my admin permissions on my admin role. So I'm going to tell CloudFormation to use those permissions. That is all fine, and hit submit. Create is in process. So we just want to refresh this a couple of times and eventually it will be created and ready on the left-hand side in green. In the meantime, if we just jump over onto GitHub, we scroll down to the setup work, you can see that we're creating the S3 bucket that we give a name for there. We're creating the glue databases to store tables, and we're creating an Athena workgroup. If you're not sure what an Athena workgroup is, there is a video on Athena on this channel. I advise you to go check that out. This shouldn't take too long, a matter of seconds, and we should be good to go. So I'm just going to refresh. Yep, and you can see create complete. So just hit that refresh in the left. If you go to outputs, you will see the name of your S3 bucket. So copy the name of the S3 bucket from outputs, and let's navigate to S3. Click on S3 and open in link. And once there, paste into the find your bucket, and your bucket should be created. I'm working out of the EU West 2 region. Whatever region you fancy, you can work out of for this. I'm just going to click in and you can see that the bucket is empty. Let's jump back onto the GitHub and take a look at the next steps of the main tutorial. Okay, so back on the GitHub, you can see I have put all the actions of the main tutorial on the README so you can follow along. What we're going to do next is upload data from the folder that we downloaded into that S3 bucket, and then we are going to create some tables, as you can see, using this code. Excellent. Let's jump back onto the S3 bucket. On the S3 bucket, let's go upload on the right-hand side. So I'm in the bucket that we created, and I'm going upload. Go to add folder, not add files, and you want to get to the data folder inside the unzip folder. So there's the CF template, there's my data folder, and where it says CSV, we want to upload the CSV folder and the taxi.csv. So we're uploading not the data folder, but the CSV folder and the taxi.csv, and click upload. Hit upload if you need to on your browser, and then hit upload down the bottom right, and that will be the data uploading. It's a couple of meg, it'll take a couple of seconds, and you can see that it has succeeded. So if we click on this link here back to our bucket, and you can see then that we have CSV and taxi data as our two folders, or our folder rather, and our file. So if you click on CSV, we have the file taxi. Okay, so this bucket, as I said, is acting as our data lake for the purposes of this demo, where we're going to store data to interact with Iceberg. But what we're actually going to use to build our Iceberg tables is AWS Athena. So type in Athena at the top, and I'm going to open this into a new tab so I can keep the S3 tab open because I can navigate to it when we need it. You want to click on the right-hand side, explore the query editor, or the hamburger menu and query editor on the left-hand side. Both get us to the same destinations. Okay, once on the Athena console, we want to go to the work group on the right up here. And we actually created a new work group during the CloudFormation template creation, and that's the Athena group Iceberg. It will ask you to acknowledge that you're going to use it. If you want to click on this link, it'll take you to the S3 bucket. I'm just going to move this down here. And this is where we're going to save our results of Athena. So that's perfect on that. And you want to acknowledge that as well. So now we have the Athena workgroup created. Okay, the next step we want to carry out is to create a couple of tables. If we jump on to the main tutorial on the GitHub, the first table we need to create is the CSV table that'll go over the data that we've just uploaded. So you want to hit this copy icon on GitHub. It's the easiest way to copy, and you want to paste. You need to change this bit of the bucket name to the bucket name that you've given for this demo. So I'm Johnny Chiver's Iceberg demo, so I'm just going to copy it from here. It's the easiest thing to do, and I'm just going to paste it in. So remove the placeholder where it is between the greater than and less than sign, and put in the name of your bucket, and then you want to run this. This will go and create a table for us. So if you go to database and you go to icebergtutorial.db, this was created during the CloudFormation template. The table that I have just created will be there. To check that it exists, if you want to type some code, if you're new to SQL, then select star from, and then you want to highlight this for speed, paste it in, semicolon, and actually we want to limit this just to save some money. Actually, this should stay in the free tier, but this will definitely keep it in the free tier. Limit it to 10, and you should have data then appearing. So we've created a table that's sitting over this CSV file that we've uploaded, and we're using Athena then to access it. This is not Apache Iceberg. This is just a CSV table using the Glue Data Catalog and Athena to access it. Okay, next steps, back onto the main tutorial. Step 3, we're going to create an Apache Iceberg table. So you want to, again, copy, delete that out, and paste. And again, where it says S3 bucket name with the greater than and less than sign, you want to replace that with your bucket name. So I'm going to copy that back to Athena, and I am going to paste that in and run. And that's off, and that is our first Apache Iceberg table we have created. Okay, let's take a little look at this code because it actually tells us what's going on. So this is just columns that we're going to populate data with. That doesn't really matter right now. But here's the interesting things from the theory before. We're partitioning by day on date, and table properties equal Iceberg. So we're creating an Iceberg table, and we're partitioning on date. If we quickly go into the demo bucket and we refresh, you can see that there has been a addition of this NYC taxi iceberg folder. So when we created the table in Athena there, we also created this folder, or Athena in the background running and creating an iceberg table, and our glue data catalog created this folder. If we click into it, you can see that there's the metadata. And inside this metadata, there's not much right now, but this is going to keep the metadata list and the metadata files that I explained in the theory. So that's what we've got to look at for now. And also, if this isn't part of the tutorial, we do have other videos on the channel on AWS Glue. But for reference, know when we run the create statement in Athena, it's actually creating these tables in AWS Glue. So if you go to AWS Glue, go to databases down the left-hand side, Iceberg tutorial, you'll see that we have created 2 tables inside the glue data catalog, and these tables are being accessed in Athena down the left-hand side. If you're new to that, as I said, plenty of videos on AWS Glue in the channel and the glue data catalog. And there's an in-depth Athena video and querying with SQL. That's not the purpose of this video. The purpose of this video is to focus on Iceberg. So that's what we're going to do. Back on to the next step, we are going to create another Iceberg table in step 4. It's got a slightly longer name, and the reason I'm creating 2 is so we can manipulate data in one and keep the other one as the original for comparison. So this is just creating another Iceberg table. Again, hit the copy icon, that's the quickest. You want to paste that in, and you want to go get your S3 name again. So I'm just going to go back up to my S3 bucket, and I find it easiest to copy from here. And again, between the greater than and less than sign with the placeholder of S3 bucket name, delete that and paste in your S3 bucket name. Run, and again you can see we're partitioning on the same column and using the date function, and again the table type is Iceberg, and you can see when it's ran also we create a new table called data manipulation appended on the end of the table name. So that's 3 tables now created inside the Iceberg tutorial database. What we need to do next is jump back on to the GitHub, scroll down, and what we're going to do is actually insert some data. So we're going to use the CSV table. This was the easiest way for me to get data in to Iceberg tables. We're going to take the CSV table, which is sitting over the CSV file. We're going to insert that data into an Iceberg table, and that data is going to change into Parquet format. And AWS and Athena are handling all this for us with Presto in behind the scenes. So again, I'm just going to copy all of that, delete it out, and paste in what we have. This should all be set up to run based on the naming conventions that I've gave, and hit run. This will take a few seconds. Okay, completed. Jump back onto the S3 bucket. Go into where that, refresh this first. Actually, that's a good point. Let's refresh this because we should have another table folder sitting there that we created. So you can see that we have that manipulation folder as well, which is sitting behind the table that we created. But again, go into the Iceberg folder, the NYC taxi Iceberg folder, and you can see now that we have a data folder. In the data folder, in behind the scenes, Iceberg is doing its thing where it is creating the data files, updating the manifest files, and updating the manifest list files. But if we click into one of these, you can see that we're partitioning by the pickup date and time. So if we just jump back on and we go up to number 2, I believe, yeah, number 2, you can, or sorry, number 3, apologies, number 3, you can see that this is our partition, but we're using a day function. However, when you look at the data and the way it's being stored on this, you can see that it's keeping the whole date. And this is a feature of Iceberg, as I explained in the intro or in the theory before this, where it is clever enough to know where all the data resides on disk. And if you do day partition, it means you can actually run year and month queries quite efficiently, because it starts to jump down this date as it runs, so it knows where everything is. If you click on the partition, then you can see that it's got a Parquet file. It's took our CSV data, it has made it into a Parquet file, it has distributed that on disk in a way that it's efficient to be queried. It has partitioned on day for the pickup time, but kept the full date because it's able to use the full date and then work down to day, as I explained in the intro, which is one of the great features of Iceberg. And then those manifest files and manifest list files have been generated and stored in the data folder above. So if we go back out to the top of the table and you go into data, or sorry, back out to the top of the table in the metadata, some of this is hidden, but you can see that it's starting to produce different files so it can keep reference, as I said in the theory. Okay, this isn't theory, this is practical. So with that in mind, let's select some data. So you can see here, looking at number 6, we're going to select data from the Iceberg table. We're going to use the day partition where we know it's being saved on disk, equal to 5, and limit that to 20. So copy that because it's easier than typing it out, and paste it in. So you can see here, if we run, we are now going down using the Iceberg table down on the disk, and we're getting where the day and date time is 5. The way that's actually working, as I said before, is in the data, and I'm probably going to pick one where it doesn't have a day 5. That's fine. The way it's working here is it's saying, okay, I want pickup date in day 5. It's going, well, ignore the year, ignore that month. So it's ignoring the first part of, or these two parts of the string, and only looking at this part of the string. But it knows all this information in files. It doesn't actually have to look at what we're looking at here. It knows this from its manifest files, and that's why it's efficient to query. Okay, let's look at the next one so we can select data. That's fantastic. Let's do some data manipulation. So to do that, we're going to have to copy the data from one table into the other. So number 7, we're just going to copy the data using Athena from the NYC taxi iceberg table into the data manipulation table. So that's what this code does. We're just copying data from one table to another. This will be pretty quick because we're already in part K. Well, quicker than the CSV, but again, it's creating those manifest files that's maintaining snapshot information. It's maintaining manifest list of the data on disk. You can see that it was quicker than the CSV creation. However, it's still creating all those metadata files to help us query. Okay, back on to GitHub again. Okay, so the next thing we want to do is update some of the data to see it change. So the purpose of this statement is the update. We're in Hive. If you're doing Hive or if you're using Spark a couple of years ago, this is kind of complicated with big tables, but Iceberg actually gives you an update functionality through Athena. So we can just use the update syntax like it would be on SQL. We're going to set passenger count to 4, where the vendor ID is 2 and the pickup date time is 2022 for the year. This is a contrived example, obviously, and what I'm really trying to get across here is that the update statement works. So if you copy and paste that in and run it, this will go down on the disk, and it might take a few seconds. So we're just updating to 4, where the vendor ID is 2 and the year is 2022. While that's running, we will hit number 9. So number 9 is to select the data that we can see that the passenger count is all updated to 4. So that was successful. It took 9 seconds to run, and we'll just paste in that next query and run it. So you can see while that's running, it's looking for 2022, where the vendor ID is 2, and then we should have changed the passenger count all to 4, as you can see, and that's me limiting to 10 just for speed. So you can see that the passenger counts have all been updated to 4. Excellent. So that's the update functionality. Really useful if you want to run updates or your data scientists want to run updates. The next thing I want to look at is the time travel query. So let's take a copy of this and go to Athena. So time travel is because Apache Iceberg is keeping snapshots of the data. It has all the history of what that data looked like. So if I paste that in, and this is a good example to show that the query before worked, and, 2022, it's longer than this. What we need to do is change the timestamp to the time before we ran the query that did the update. So today is Saturday, the 26th of November. So that would be 26th, and then I'm going to set the time to 17:30. So or 19:30 rather. You'll need to set this to the time that you have, and make sure it's at least 1 minute, or you wait 1 minute from when we manipulated the data. And if we run it, we'll get to see what the data looked like before we changed it all to 4. So this is going into the database. It's grabbing the passenger count, and it's saying, well, actually the data looked like that 1 minute ago, which it probably did. So let's change that to 25 and see if that works. Should have took a note of when I ran that query. Would have made this easier. Yeah, 25. You can see the passenger count here, for example, is blank on those top 10 rows. Let's build this out and take off the limit just to have a little look at the data. So I've removed the limit. You do pay for the data that you scan. So this is how you know how much it costs. It's $5 per terabit, but you can see I'm just using 33 meg there. So in this example, you can see that there's a whole load of passenger counts that are 0 or not there, not there, not there. And then you can see that it starts to come in at like 1, 1, 1, 1. So there's just 2, there's a 2, there's a 1. You get the picture, right? And If we then take off the timestamp, so this is the bit that's doing the time travel right here. If we delete this time travel bit, so cut that out, and we run it now, they'll all say 4 because we updated it to 4 in this data manipulation table. So we've updated that whole column to 4 using the update statement, which is the feature of Iceberg, and you can see everything is 4. But with time travel, we can go back and see how that table looked a few minutes ago. So that's the power of time travel. With the update, you get the history of how your data looked in Iceberg. And then finally, the last big feature that I absolutely love in Iceberg is to delete the data. So let's copy that in. So again, you have delete functionality in Iceberg. So if we delete, and let's change that to 2022 instead of 2008, and we run, we're going to delete all the data in the manipulation table that does not equal 2022. I'm not sure if there is any, so let's figure this out. Let's select from the table now and see if we've just been left, just to make sure that we don't have any data left. So that should have deleted everything that wasn't equal to 2022, so we shouldn't get anything back. Yeah, no data. And then if we put equal to 2022, we should get all the data back that's left in the table. Yeah, so everything here should be 2022. You can see 2022. And then, as this is the last bit of the demo, put in delete, get rid of the star, get rid of the where, and we'll just delete everything out of the table. And you can see the delete functionality working in full, where it's deleting from the table in Iceberg, deleting all that data for us, and then we'll have nothing left. So this will take a few seconds to run because it's going to keep update all those manifest files and say delete the data, delete the data, delete the data. And then when we do select star, there'll be no data left in the table to be shown currently, hopefully, if the delete ran. And there you go, no data in the table. So that's the power of the delete, the power of the time travel, the power of the update. And then as well, before we go, the great thing about Iceberg is that concurrent query. So if you want, you can hit one select in here, then you want to hit the add button. And what we want to do is just copy this a couple of times. So the beauty of Iceberg with its ACID transactions, when I run 2 queries like this, there's ACID transactions, so they won't read the data dirty. They will get the same view of the data at the same time and bring it back to us. If we were updating in the background, then the table is locked. Those selects will wait and then run on the new data, so it prevents the dirty reads. So that's a little bonus there, where you can run multiple selects and updates all at the same time, and the ACID principles of the table are held in the metadata file. Okay, the last thing to do is to delete what you ran. So if you go into CloudFormation and click delete, this will delete all the resources. You will have to delete all the data out of the S3 bucket first. So delete the data out of the S3 bucket, then click this delete, and that will clean up all the resources. Join me back off the console and we'll just do a wrap up of what we looked at today. Congratulations everybody, that's the end of the tutorial. You've now been through how to set up an Iceberg table, manipulate the data in that table, and query it. I hope you found this lesson useful. I have more on my website for free, www.johnnychivers.co.uk. And until next time guys, thanks for watching.